Hi, good morning. This is to introduce chapter 14, this video. And here we are going to talk about heat and how really materials interact with heat. The first thing is we're going to go back to the definition of heat as the energy transferred when there is a difference in temperature. Okay, then only when there is a difference in temperature, there going to be a transfer of heat. Heat can be measured in 3 units. The first one is joules because based on the definition that it is energy. The old unit, CAL, calorie, and this is here the food calorie. 1 food calorie is 1000 calories. 1 calorie is 4.186 joules. Now the question is, if two different materials they were given the same amount of heat, does the you know I would say does the change in temperature is going to be the same or is going to be different? Okay, what determines this is the specific heat capacity. Okay, then materials react to when they absorb heat or when they eject heat based on this number, which is called specific heat capacity. We use for it lowercase c. And use for the quantity of heat, MCAT, M times C times delta T. M here is the mass of the substance, and I like always to use standard unit, then it is a kilogram. Here temperature, you can keep them Celsius because it's a difference, then it will cancel if you convert. And a Q here is the amount of heat or the quantity, this is why it is Q, the quantity of heat needed to change the temperature by this amount. For the specific heat, we have units of joule per kilogram Celsius or joules per kilogram Kelvin. Now, the first question here is show that 1 calorie per gram times degrees Celsius equals 1 kilocalorie per kilogram Celsius. And here I can easily do the calculation. 1 calorie divided by gram Celsius. Okay, I want to change the units for calorie to kilocalorie. Then 1 kilocalorie is 1000 calorie. For the gram, 1000 gram is 1 kilogram. And then the grams, they're gonna cancel. And the calories, they're gonna cancel. And then the 1000 is gonna cancel. And based on that, what is gonna be left over? Kilocalories per kilogram Celsius. This is a question about how to use the equation. And here I have 0.25 kilograms blocks of a pure material is heated from 20 degrees Celsius to 65 degrees Celsius by the addition of 4.35 kilojoules of energy. Calculate its specific heat and identify the substance of which it is most likely composed. Now I need to have my quantities here. This is the mass. This is the initial temperature. This is the final temperature. Now the energy, I have converted this into joules by multiplying by 1000 because kilo means 1000. Q equals mc delta T, then C it is Q divided by m delta T, and therefore it's going to be 4350 joules divided by 0.25 kilograms times 45, which is the difference in the temperatures, and therefore C was calculated to be 387 joules per kilogram degree Celsius, and that one it is for copper. Here another example, talking about exercising and how the temperature of our bodies is going to increase, and then we need to have a mechanism to actually to emit this heat again so that we will be able to live healthy. Now, during or like following vigorous exercise, the body temperature of an 80 kilogram person is 40 degrees Celsius. At what rate in watts must the person transfer thermal heat to reduce the body temperature to 37 in 30 minutes? Assuming also the body continues to produce energy at a rate of 150 watt, well, then we're gonna calculate what is the total rate. Now here I have the mass is 80 kilograms and TI is 40, T final is 37, and the time is 30 minutes. Then Q can be calculated as M times C human times delta T. This should be given to you, all right? And therefore, the the body should lose this amount of heat. If I want to calculate this as a rate of heat transfer, then I'm gonna have Q over T 8.40 10 to the 5 joules, and 30 minutes I need to convert it into seconds, and then I have calculated what is the rate of losing heat, and then finally the total rate should be for the P, which is power for the cooling and power for body, and then I added these together to give 617. Now this equation here, I will say, given that no phase change. Okay, when there is a phase change, we're gonna deal with that in the next video. Then here I'm gonna stop, and I'm gonna see you in another video.